In this video, we're going to look at energy consumption. So the first thing to consider is how we rely on energy. All that energy we talked about previously in terms of fossil fuels and things like that, what do we actually use it for? We can actually use this in a lot of different ways. Think about something that you do. Behind it lies a complex story about the energy resources that made that possible. For example, you might get your energy during the day by eating a sandwich. But what energy resources were needed to bring that sandwich to your plate in the first place? The diagram on the right shows just some of these things. We would have needed things like diesel, which is a fossil fuel, to run the tractor that harvested the wheat in the first place. We would have needed electricity to run the fridge that kept your sandwich fresh. We would have needed gas for the oven that baked the bread in the first place, petrol for the truck that delivered the bread to the shop, petrol for the car that took it from the shop to your house, electricity for the pump that milked the cow, for the milk to make the butter and the cheese. So when you think about the simplest thing as a sandwich, there's a huge amount of different energy and processes and things that went into it just to make that one thing. So it's a very energy intensive process when you look at its origin and how it came to be. We get energy from fossil fuels by burning them. But as I said in the last video, this doesn't explicitly give us electricity, but we can use it to produce heat. And we use that heat to generate electricity. Sometimes we use the heat directly. So in a natural gas oven, for example, we can burn the gas to get the heat explicitly, and we've used it directly. Things like water heaters and other heating solutions, sometimes we'll also use a similar concept that will burn the gas directly to then harvest that heat for our houses or our food and things like that. In a lot of fossil fuels we burn in the vehicles, we explode this petrol and the diesel in the engine, and this directs the force through the engine, the gearbox, etc., and turns the wheels. So we're using that explosive power of the fossil fuel to then turn the wheels and power or move the car. A lot of fossil fuels, in particular coal, we burn in power stations just to make the electricity. So its purpose is to burn, but the burning process is what generates electricity, not necessarily the coal itself. To do this, we use turbines and generators. The fuel is burnt and this boils water. So the whole purpose of it is boiling water, really. We use the coal, we burn it in these very hot fires, that boils water. Boiling water creates steam. The steam rises quite powerfully, and this forces the blades of a turbine to spin, just like a propeller blade. So as it rises, it hits these fan blades, causes them to start spinning. This spinning turbine turns a generator, and the generator is the thing that creates electricity. So ultimately, to generate electricity, we just need something that turns a generator. And in a lot of cases, we fit turbine blades to it, and we have steam or something like that running through it. Turns the generator, generates our electricity. So the coal is just the means to do that. It's not generating the electricity directly. This is an example of the process from start to finish. On the left, we've got the coal that's been dug up, so we've excluded the whole process of that. We've got our train, the coal is brought in, the coal is burnt, that heats the water boils, which turns to steam. The steam then is directed through the turbine blades, spins the generator, generates our electricity. We then redirect the steam back through these big cooling towers just to cool it back into water, and then we can pump it back through the furnace again. So it's what we call a closed loop. We're not actually losing the steam, but we're heating it, we cool it in here, we pump it back through and reheat it. So we use the same water over and over again, just constantly cycling. And then we get the electricity, which we use for all of our devices. So again, just like the sandwich, it's a lengthy process just to be able to flick your light switch on and have electricity there, or plug your laptop into the charger in the wall. This is the whole process that's involved in making that happen. How much coal though? This is something to consider. Let's say it takes 8 tons of coal per minute to keep a 60-watt light globe on in every house in France. So every minute that's 8 tons of coal being burnt. How many tons of coal would need to keep all those globes going for 1 hour? So if 8 tons per minute, how many tons for 1 hour? To do this, it's a bit of maths. If it's 8 tons per minute, how many minutes in an hour? There are 60 minutes, so it'd be 60 times 8. That's how many tons of coal for 1 hour. That is a huge number. And that's pretty accurate. That's about how many tons of coal it takes for every house in France. So that's a huge amount of coal consumption just for 1 hour to have lights on. So this gives you some perspective now on why it's so important to turn off your light. If you think about that's just a 60-watt globe. So by turning that off, if every house in France did that for an hour that they weren't in the room, you would save 8 tons of coal. This graph on the left shows how much coal we've been using since the Industrial Revolution. You've got different factors here. So we've got oil, coal is our grey one. Gas has increased a huge amount, hydro started to spike, and other renewables. But you can see way back here, around the Industrial Revolution, we used a very small amount. And then as we go on, we started to improve our technology, increase the amount of electronic devices we had, all this sort of stuff. You can see that the demand and the use of coal and oil has increased significantly. So in 2013, when this thing was done, we were using 30% between oil and coal, 21% gas, and very, very small amounts of hydro and other renewables. So our renewables are the things we've talked about that can actually be replaced. And we're using about 1% in 2013, whereas the rest of it, the 98%, was fossil fuels and non-renewables. So this is the process for calculating the question from above. We know that the total amount of coal needed is the number of tons per minute times the number of minutes. We had 8 tons of coal per minute, and there are 60 minutes in 1 hour. So we do our 8 tons per minute times 60 minutes, 480 tons of coal every hour to power a light globe in France, for everyone to have one light globe in France. That's huge. From here, there is a style energy quiz, which the link is available to you in the next section. Complete this and proceed on to the next topic.